After the general support information, we will now look into the product details and start with the premium HVS and HVM. First, a short product overview. The HVS consists of 2 to 5 modules per tower connected in series, whereas each module has about 100 volt. The HVM consists of 3 up to 8 modules per tower, whereas each module has about 50 volt. Up to 3 towers with the same module configuration can be put in parallel. To know which configuration is compatible with which inverter, the most recent compatible inverter list has to be regarded. Only configurations and inverters listed and released in this list are allowed to be used with the BYD batteries. For other or not released configurations, the warranty will be voided. The latest list can be downloaded in the BYD battery box or EFT-Systems website. After making sure the configuration is correct, we will now look into the installation of the product. For the handling of the battery box, please always refer to the official manuals by BYD available again at the stated web pages. The installation and all other kinds of works or measurements in combination with the battery box are only allowed by professional and qualified electricians and according to national and international regulations. The handling of the battery is held as easy and safe as possible, but please be aware that improper handling could damage the batteries and lead to dangers. Wear proper safety gear. Here you see the requirements for the installation location. The temperature range is from -10 degrees to +50 degrees. The battery can operate within this temperature range, however, the power will be limited below 5 degrees. The battery should not be placed close to easily inflammable materials. The premium HVE batteries have a protection rating of IP55. They can be placed outside, however, the battery should not be exposed to direct weather conditions like sunshine, rain, or snow. For the installation, you need 2 parts and packages of the battery box: the base and the BCU, which is a battery control unit, and the modules. In the package with the BCU and base, you will find some documents, as well as the parts for the wall mounting. In the module package, you will find the module and the screws to fix the modules on top of each other. For the installation, you will additionally need, per battery box tower, the DC cables, the screws and bolt for the wall fixation, the communication cable with cut 5 or higher, and the ground cable. When setting up the tower, it is important not to mix HVS and HVM modules. The different modules can be easily differentiated by the lines in the front of the modules. 1 line for HVS modules and 2 lines for HVM modules. The BCU is the same for both versions. Here is shown what is allowed or not possible for one tower configuration. Important here is a correct module quantity and to not mix HVS and HVM modules. For the parallel connection, there are also some limitations. Up to 3 towers can be connected in parallel. For this, all towers need to have the same module quantity and thus the same voltage. Furthermore, it is not possible to mix HVS and HVM towers in a parallel system. And again, please refer to the compatible inverter list to check which configurations will work with which inverter. With those limitations in mind, we will look into the installation, which is held as simple as possible and which is shown in principle on this page. The base is placed on the floor and the modules are simply stacked on top without any internal cabling. The modules can then be fixed with screws on top of each other. Finally, the BCU is placed on the top module and attached to the wall. The next step will be the external cable connection on the left side of the BCU. Make sure the system switch is off before you start. Then open the connection area. Here you see the ports available in the connection area. You have the communication ports to the inverter, the ports for the parallel connection, the ground, the Ethernet port, the DC cables port, and the dip switches. First, connect the ground cable. It is important to connect the battery directly to the ground of the house. Do not connect the battery ground to the inverter ground, as this might lead to communication problems. Next will be the communication cable to the inverter. For most inverters, you can choose between two connection options. For all inverters, you can use option C and connect the communication cable by pins. Dependent on the inverter, you might also have the option to connect the communication cable by a normal RJ45 head on the inverter cable. Please always refer to the manual to check how the combined inverter has to be connected. An example for the connection with an inverter is shown in this slide. You see that this inverter has two connection options. On the left side, you see the option with a RJ45 cable head. On the right side, the option with a pin connection. It is very important to make sure the connection is done correctly and with a Cat5 or higher cable. Otherwise, the system might not work. If you face problems, test the cable or try another cable, or try the other connection option if available for the inverter. Besides the correct cabling, also dip switch configuration is important. Different inverters have a different dip switch setting, so please always make sure you are using the setting described in the manual. In this picture, all dip switches are on the left position, but this is different dependent on the inverter. A wrong dip switch configuration could again prevent the system from working, so please always check the correct position of the three switches. Next is an Ethernet cable to establish an internet connection. It is optional, but we highly recommend it to allow for remote updates and remote service. The DC cable connection is shown here. You can see the DC cables, and you can use DC cables with up to 16 square millimeters. After connecting all cables, close the cover. The battery cannot be started if the cover is not closed correctly. Now, the cabling for a parallel connection of 2 or 3 HVS or HVM towers with the same module quantity is described. Each battery needs to be grounded. The batteries will be connected with each other with a normal Ethernet cable. Please make sure to use the correct in and out ports for the parallel connection as shown here. If 3 batteries are in use, the dip switch position of the middle battery needs to be changed according to the picture. The communication cable to the inverter is then from the master BCU to the inverter exactly as you would only connect one battery. For the internet connection, again, only the master BCU needs to be connected. The DC cables should be collected and then one DC string will go to the inverter. Here, all DC cables should have the same length and parameters to avoid a difference in voltage on the different batteries. Dependent on the DC cables to be used, it is further important to mind the regulations regarding the protection of the cable routes. Additional fuses to protect the cabling might be necessary. This can be self-made, or there are also third company suppliers that offer off-the-shelf combiner boxes or butt breakers. BYD also offers an optional in-house solution to simplify the DC cabling with a premium HV combiner box. Here, basically all DC cables and the ground cables of the different towers are collected. Internal fuses protecting the cabling enable smaller cable cross-sections that might be necessary for the inverter. Here, the complete cabling for a parallel system with 3 towers and the HV combiner box is shown. After the cabling is complete, the next step is commissioning. For this, the battery needs to be activated by the system switch on the right side of the BCU. Here, the correct switch on order is important. If there is a switch between the inverter and the battery, that needs to be turned on first. After this, the battery needs to be started and configured. The configuration of the battery is done through the app BConnect, which can be found in Android and Apple app stores. Make sure to use the latest version of the app. Upon recording of this training, the version is 1.7.1. So make sure the app on your mobile device is at least this version. When starting the app, the version is shown on the same page where the language can be selected. After confirming, the app will download the latest firmware and parameter table automatically. Please download the latest app and the latest firmware in the office before you go to the customer to make sure you have a stable internet connection for the download. Also, check regularly if there is a new version and download it. You can pause this video now to check the app version on your mobile device and possibly update or reinstall it to the latest version 1.7.1 or higher. After this, please also download the latest firmware inside the app. When you have the latest firmware, you can connect to the Wi-Fi of the battery. The password is BYD B-box as shown here. Please mind the small and capital letters. Be aware that the Wi-Fi will turn off automatically after 5 hours. To reactivate, press the LED button or restart the system. When you are connected, update the firmware to the battery. You will see the versions in the app and on the battery. For the update, it is important to know that the BCU consists of two components, the BMU and the BMS. With the update, you will update immediately the BMU, which will then update the BMS. This can take up to 20 minutes until the BMS is updated, but you can already continue with the configuration. The firmware versions for the battery box HVS or HVM needs to be at least BMU version 3.13 and BMS version 3.19. The configuration then asks only for very few pieces of information: the current time, the inverter, the battery configuration, the type of use, and phases. If multiple batteries are in the system, you only need to update and configure the master battery. As shown here, you can identify the correct Wi-Fi of the master by the Wi-Fi name you can find at the system switch of the master BCU. You should be able to see if the configuration of the parallel system was successful when the LEDs of the slave towers turn white and the Wi-Fi of the slave towers disappear. After the update and the configuration is done, you can switch on the inverter. Please install and configure the inverter based on the manual and requirements of the inverter manufacturer. In general, the startup procedure for the system should be first the switch between the battery and the inverter, if there is any, then the battery or the batteries, and then the inverter. When the battery is on, the LED on the BCU will show a status. White blinking is, for example, normal for charging or discharging. A white and blue flashing is normal for the startup phase or when the SoC is low. But based on the sequence, a white and blue blinking can also show an event code. For this, the number of blue blinks between white blinking has to be counted. In the service guideline, you will find further information and what to do. For switching off the system, it is exactly the other way around than switching on. First the inverter, then the battery. To switch off the battery, the LED button should be pressed for 5 seconds. Then the system switch will fall automatically. If there are problems with the system and it cannot be put into full operation, it is very important to always switch off the battery completely before leaving the system. Here, all LEDs should be completely off. Also, the system should then be put into operation within a few days, or the service should be contacted. Please note that an improper handling can damage the batteries. If the battery should be extended later or a module is exchanged, it is very important to have a similar state of charge in all modules. As new modules arrive with about 25 to 30% SOC, the original battery should be turned off at about the same SOC. Then the new module can be simply added. After this, the configuration has to be done again with the new module quantity. We recommend involving the end customer, who can simply switch off the existing system at 25 to 30% by pressing the LED button, so that the installer only has to insert the new module and reconfigure the system. The same state of charge in all modules is necessary because of the direct series connection of the modules without a DC-DC converter. This, in turn, is responsible for the very high efficiency of the system.